Hello, and welcome back to another episode of Low Spec Labs. Before we get started with this chapter, I would like to stop and say thank you to you. That's right, thank you for commenting, thank you for liking, thank you for subscribing. If you're new to the channel and you would like to continue to receive this informational IT content, or you would like to receive the occasional automotive content, please go ahead and hit subscribe. Otherwise, let's go ahead and start with this chapter. This chapter covers SE Linux, so that leaves us a question: what is SE Linux? SE Linux, otherwise known as Security Enhanced Linux, is a security feature that was actually developed in combination between the NSA and Red Hat. That's right, boys, SE Linux was developed by one of the three-letter agencies. Put on your paranoia caps and take that for what you will. Considering the fact that the Glowies developed this for themselves, it probably works just fine, and it's also open source, so if there are any issues with it, realistically they would have been discovered by now. SE Linux is what is known as a mandatory access control system, and its job is to limit what applications have access to what resources on a system, as well as what users have access to what resources on a system. SE Linux can be used to lock down files, ports, services, and lots of other stuff. More often than not, when you're working with SE Linux, you'll be trying to figure out why something isn't working, rather than trying to actually lock people out. That's mostly because SE Linux can be very restrictive if it's not properly configured. And if you don't know what you're doing, it's very easy to misconfigure SE Linux. And also, if you don't know what you're doing, it's very hard to troubleshoot what exactly is going on because there's multiple layers. SE Linux is basically a security layer on top of your already running services. So if you have SE Linux running, you first have to validate that your services are actually running. If you were troubleshooting a service, you then have to validate that you have the right file permissions for the service to work. And then you have to go into SE Linux and verify you have the right SE Linux permissions. So there's another layer on top of your system that makes it more difficult to troubleshoot. Many Linux admins complain about SE Linux. Having read through this chapter, I see why. SE Linux is a complicated topic to talk about. So complicated, I need to give you some definitions so you know what I mean when I say certain words. So, what is an SE Linux policy? An SE Linux policy is a set of rules that defines which source domain has access to which target domains. What is a source domain? Well, within SE Linux, a source domain is the object trying to access a resource. So, for instance, that would normally be a process or a user. What is an SE Linux target domain? An SE Linux target domain is the resource that the source domain is trying to access. So this is normally files or network ports, but it could be a few other things as well. What is context in SE Linux? Context refers to a security label used to categorize in an object. When we get deeper into these videos, we'll talk about SE Linux labels and the different types of labels. What is an SE Linux rule? An SE Linux rule is a part of an SE Linux policy. So a policy is a collection of rules, and the rule itself defines which source domain has access to which target domain. And then of course there's your SE Linux label, otherwise known as an SE Linux context label, right? And the rule defines what has access, but the label defines what is a source and what is a target. So what are the three SE Linux modes? Because there are three modes you can place SE Linux in. The first mode is enabled. This is turned on by default in the newest versions of RHEL. What that means is the SE Linux policies are applied and enforced. The second mode that you can place SE Linux into is permissive. What this means is SE Linux is going to keep track of your policies and your rules, but it is not going to enforce them. This is a great way for you to troubleshoot issues with SE Linux or for you to test changes before you apply them. The third mode is disabled, where you just straight up turn off SE Linux. If you want to keep your system as secure as possible, don't turn off SE Linux. But a lot of admins who don't want to learn how to administer SE Linux just go ahead and turn it off, because it is somewhat confusing and tedious to leave it enabled when you don't know how to configure it. Where is the configuration file for SE Linux kept? Configuration files for SE Linux are kept at etc sysconfig SE Linux. Let's go ahead and open up that file and take a look at it. Of course, you're going to want to enter your password for your admin account. And as you can see right here, SE Linux is currently set to enforcing. You are also going to need to know where the SE Linux logs are. Where are your SE Linux logs kept? Your SE Linux logs are kept at var log audit.log. Let's go ahead and try tailing the output of that to see what exactly it's showing us. So as you can see, all these messages are SE Linux logs, and all of them are telling us what exactly happens on the system. You'll get these logs when your SE Linux is placed in enforced or permissive mode. Now that we know some foundational information, let's go ahead and dive into managing SE Linux. How do you actually manage SE Linux? The easiest way to learn is with practical examples. I've pulled up our virtual machine, and we're going to run through some basic commands to get information about SE Linux. The first thing you'll want to do when you log into a server is check if SE Linux is actually running. How do we get this SE Linux information? Well, you pull up your server, and there's two commands you're going to want to use. The first is get enforce. And as you can see, it tells us our current SE Linux status, which is enforcing. That tells us if SE Linux is enforcing, permissive, or disabled, but we can get even more information with another command. That command is SE status. So let's do sudo SE status -v. Then we've got to enter our password. And as you can see, we get even more information about SE Linux. We get the file system, we get if it's enforced, we get the mount, we get the root directory, we get the policy mode, we even get our current context. There's lots of useful information we can pull with SE status. How do you change your SE Linux mode? There is a command for that. That command is set enforce. So set enforce has two options. We can either set it to 0, which will place SE Linux in permissive mode, or we can set it to change our SE Linux status. We use set enforce. So set enforce has two modes. We have set enforce 0, which we use to set SE Linux into permissive mode, and then we have set enforce 1, which we use to set SE Linux to enabled. So if we were to do sudo set enforce 0 and then enter our password, and then we were to do get enforce, you'll see SE Linux status has now changed to permissive. We can then change that back by doing set enforce 1, and then we run get enforce again, and you'll see SE Linux is now set to enforcing. Something to keep in mind is using set enforce only works for the current boot process. So as soon as you reboot this server, it's going to go back to whatever is configured. The configuration settings set in etc sysconfig SE Linux is automatically going to reapply. So as soon as we reboot the server, this setting right here will reapply. So for the setting to persist across reboots, we'd have to open etc sysconfig SE Linux and then set SE Linux to permissive in this text right here. What is a XE Linux context label? That's somewhat difficult to explain, but I'll do my best. SE Linux context labels can be applied to the following: files and directories, ports, processes, and users. Context labels do two things. They define the source domain and target domain of an object, but they also label the type of SE Linux object that SE Linux is handling. Let's look at some example SE Linux labels and break this down. So how do you actually read context labels? Let's pull up our virtual machine and take a look. How do we view context labels on files? That's simple enough. If we were to do an ls dash alh capital Z, and then we were to point it to something like our root folder, you could see we get our files, but we have an additional field here. And that additional field is right here, where it shows us the context label for our system. So what exactly does all this mean? Let's break it down. So the first part of your SELinux context label is the user. Your SELinux users are different from your users on your actual Linux system. They're two different users. Keep that in mind. How do you recognize that this is your SELinux user? Well, it's the first part of your SELinux context label. And if you pay attention, you'll notice that it also has that system_u. Everything that has _u in SELinux is a user. The next part of your context label is the role. If you notice here, you'll see that we have the role named object, and most roles inside of our file system are going to be called objects. The SELinux role can be identified inside of the SELinux label by the _r. You see right here where it says object_r. The last part of your SELinux role is the type. If we were to pull up our terminal right here, you'll see that these files actually have a bunch of different types. So for instance, right here we have temp-t, then we have var-t, then we have var-run-t, admin home-t. So even though most of them have a user of system and a role of object, their types are completely different based on what they're being used for. Out of all of these, the one you are going to be editing the most is going to be the type. So we know how to read context labels, and we know how to pull context labels for files. How do we pull context labels for other stuff like processes or network ports? Let's find out. So how do we view context labels for processes? Well, do you remember how we view processes in general? We do ps-aux, and as you can see, we get an output that shows the different processes and processes IDs. Now, if you were to do a ps-zaux, we still get our processes, but now we get the context labels for those processes. As you can see, like before, we have unconfined, or system is our user. We have unconfined as our role, and then we have unconfined as our type. You can also see down here we have some of these have a type of kernel, a role of system, and a user of system. How do we view the context labels of network ports? Well, to view network ports, we use the ss command. So let's play with that. So how do we view the context labels for network ports? Well, just like the other commands, we can do a ss-Z. As you can see, it prints out our network ports that are open, and then it prints out the context labels for those ports. So just like before, we have a user assigned to our network port, we have a role assigned to our network port, and then we have a type assigned to the network port. As you can see, the user is unconfined, the role is unconfined, and the type is unconfined. So we know how to read SELinux context labels, and we now know how to pull context labels for files, processes, and network ports. How do we actually set and change context labels? Well, let's find out. Oftentimes when you have a process, port, or service not working on Linux, and you have SELinux enabled, the reason it's not working is because the context label type is not set correctly. How do we set the context label type? To do that, we can use the scmanage command. Okay, so the best way to learn is to practice, right? Let's go ahead and try to make a folder and set the context labels. First, we're going to want to go ahead and make a directory called web. Cool. Then we're going to want to make a file inside of the directory called index.html. So we can do sudo nano /web/index.html. Inside here, we're going to put some text. and save it. Now we can go ahead and edit Apache, so let's do that. nano/etc httpd conf, then httpd.conf, and there we go. And what we want to do inside of the httpd folder is create a new directive. So how do we create a new directive? Well, we scroll down to our document root directive right here. We add 2 lines of space, and then we can just add another directory. So we do directory, and then we close the directory over on this side. We add 4 spaces, and then we can put allow override none, and then we type in require all granted. Quite done yet. What we do is we go back here, and then we put in the path to our new web folder. So we put in /web. We're not quite done yet. We then have to change our document root as well. So we go back to document root, and we change this to /web, and we save, and there we go. If we were to then open up Firefox and go to localhost, you'll see this is not the web page we just created. In fact, it is the Alma Linux default web page provided by Apache. So what we're gonna have to do is go back in and set the SE Linux context on that index.html file we created. To verify that it's an SE Linux issue, what we can do is go in and do set enforce 0, then we restart httpd. Then if we were to switch back to our Firefox browser, and then we refresh this page, you'll see it now changes to welcome to my server, which is the file we created. That tells me that it's an SE Linux issue, because when we disabled SE Linux, it works. Obviously, you can't leave SE Linux disabled if you actually want to use the security features. So how do we get this website to display with SE Linux enabled? Well, to do that, we're going to have to fix our context labels. Let's give that a shot. We can use the SE manage command to achieve that. So it's as simple as SE manage f context -a-t. So -a adds the label, -t tells us we are changing the context type. Then we enter the label, we type in httpd content, and then of course we have the -t for our label, and then we point it to the path for our root. So we can do that using web, and then because we want to include all the subfolders in web, we're going to do parentheses, quote, dot, and then we're going to use a wildcard to match everything, and then we close it up, and there we go. But we're not quite done yet. We've applied the context labels, but we have to go and relabel the subfolders and files inside of that folder. So how do we do that? We do restore con -r-v/web. There we go. Now let's run an ls-alhz/web, right? And when you look at /web, you'll see we now have a new context label type on our index.html, right? And it says http sys content t. So what we can do is then do set enforce 1. And then if we were to go back to our Firefox, you'll see the site is not working again. First, let's verify our SE Linux status. So let's do get enforce. So you can see it's enforcing. So we've got Firefox open again, and we're just going to go back to localhost. So we do localhost, and as you can see, with SE Linux enabled, it now says welcome to my server, and that's because we've applied the correct context label. So SE Linux needs both the context label set properly and the permissions set properly for it to work. To properly set context labels, you're going to need to know what the context labels are of current applications. How do you read context labels of current files, processes, ports, and applications? Let's find out. To read the context labels of current applications, you can do something like man-k _SE Linux. And as you can see, we have a problem. The utility that holds our various SE Linux context labels is not installed. You might run into this on a system where this has not been properly configured. So what can we do? Well, we can try searching for our SE Linux context label. So let's do DNF search SE Linux. So you can see we have a bunch of different SE Linux utilities. One of these contains a set of different context labels for different utilities. So what we have to do is find the right one. And the one we're looking for is SE Linux policy doc, which is right here. So we know SE Linux policy doc contains various context labels. To install it, we do DNF install SE Linux policy doc. Of course, we hit yes and we let it run. And it is now complete. We still have to update the database for man pages. So we do man db and there we go. Now we can do man-k underscore SE Linux. And as you can see, we now have a bunch of SE Linux man pages for different applications. So if we were to do man-k SE Linux grep SSH, you can see we can now pull up the SE Linux SSH. So let's do man SSH underscore SE Linux. And we now have a page or document that explains everything or all the different context labels we can set to SSH. And it's actually very thorough. So if you ever need help setting SE Linux context labels for an application, that's how you solve it. How are context settings applied? Well, there are 3 general rules when you create a new file or you move a file. Let's walk through them. If a new file is created, it inherits its context settings from its parent folder or directory. If a file is copied to a directory, it is considered a new file. So that copy file also inherits its context labels from its parent folder or directory. And last but not least, if you copy a file using something like cp-a, that newly copied file retains its context labels from the original folder or directory. Just a couple minutes ago, we used the restoreCon command to set the context label on our index.html file. That's fine, but what if we have a system where the context labels have been completely foobarred? What do we do then? Well, restoreCon can actually set the context labels back to default for most files and folders on your system. So there's 2 ways we can use restoreCon to reset the file system labels on a Linux server. The first is actually using the restoreCon command and adding the right flags. The second is creating a .autorelabel file. We're going to do both of these. Recall, to view your context labels, we use the -z flag. So we do ls-z/etc hosts. And as you can see, we have a user of system, a role of object, and then our type is netconft, which is right here. What happens if we copy our etc hosts file to our local directory? Let's try that. We can do cp, notice we have no flags, /etc hosts, and then we want to copy it to our local folder. Then if we do ls-z on our local directory, you'll see we now have our etc host file right here, and the user has changed, the role has changed, and the type has changed as well. Recall that when you copy a file, it inherits the context labels from the directory you're copying it to. What happens if we then move that hosts file back over to etc hosts? So let's do move/hosts/etc. It says overwrite. Yeah, there we go. Now we're doing ls-z/etc hosts. You'll see the context label has changed between this line and this line. It went from system object netconft to unconfined object r admin home t. And what that just did was break our system's ability to resolve hosts without DNS. So we know the context label for that file is wrong. How do we fix it? Well, it's simple. We do restoreCon-v/etc hosts. And as you can see, it changed the context label automatically because the Red Hat system, or most Linux systems, actually keep a database of context labels and the files they're associated with. What if you wanted to restore the context label? So to restore the context label to the entire file system is pretty easy. You create a file, it can be empty, called dot auto relabel. And then after that, we're going to reboot our server. So we got the server pulled back up here. Let's run a quick reboot, and then you'll see what I'm talking about. And during the boot process, because that auto relabel file is there, you should see in the command line as our system boots up that Selinux is automatically relabeling our file system. So let's see if we can catch it. You see right there, it says running sbin fix files -to restore. That tells us that Selinux is automatically re-context labeling all the files on the system. If you have a freshly installed system, this should take about 5 to 10 minutes. If you have a server with lots of files, it's going to take a while. So be very careful with this command, especially if you're using it in production. Files are not the only thing that need context labels. Your port requires context labels as well. So how do we set port context labels? If you guessed the command was manage port, you'd be right. Congratulations. Aren't you very smart? Let's walk through an example of using manage port. We're going to use Apache server as our test mule again. So what we do is we open up Apache, then we scroll down, and we simply change our listen port to port 82. Now what happens when we attempt to restart Apache? As you can see, we got an error message. Now, let's see what that error message is. It says right here that permission is denied to the socket. So basically, our Selinux label is not going to let us start HTTPD because we haven't enabled the right context for it. We can also confirm this is a context label issue by simply disabling Selinux. So again, we can do set enforce 0, and then we can go back and restart HTTPD, and you can see it started successfully. If we were to do a system ctl status HTTPD, right there, Apache is running. But again, a system that has Selinux disabled is not very secure. So what do? First, we start by disabling HTTPD. Then we can use set enforce to re-enable Selinux. Then we have to use manage port to set the right context label on port 82. So we do manage port -a to add -t for type, and then we enter the name of the port. Then we actually put in the port itself. So we type in -p, we put in our protocol, which is TCP, and then we put in the port number, which is 82. And we wait a second. Then after that, we can restart. Now when we do status HTTPD, you can see the service is successfully running on port 82. What are Selinux booleans? Selinux booleans are a way to change multiple Selinux rules at the same time. Let's dive deep into that subject. How do you manage Selinux booleans? Let's find out. In order to manage Selinux booleans, you first have to get a list of the booleans you need. So we can do get sebool -a, and then we're going to filter this down to something like our FTP server. So as you can see, all the booleans for our FTP server have been turned off. So basically, if we had FTP enabled, right, anonymous write would be off, connect all reserved would be off, full access would be off. The various features of FTP wouldn't work because Selinux is told to not allow writes. Our next step is to then turn FTP writes on. How do we do that? Well, thanks to boolean commands, it's pretty easy, especially compared to previous Selinux configs. We do a set sebool, then we type in the name of the boolean rule we want to change, then we just turn it on. Now, when we run getBool, you'll notice it changed from off up here to on down here. This is good that on writes is on, but this change is not permanent. As soon as we reboot the server, it's going to go back to default. So how do we make it permanent? First, we have to verify that it is actually not set to permanently be on. How do we do that? We use manage boolean -l grep ftpd anon. So if we pay attention here, you'll notice we have two options. It shows that the runtime configuration is on, but the permanent configuration is off. So how do we turn the permanent configuration on? It's pretty straightforward. We set sebool -p and then ftpd anon right. Now when we run the semanage boolean l command, you'll see both these flags are on. So now this setting will persist after a reboot. We are almost done with this SELinux video. After 30 minutes, no doubt you're tired of hearing my voice. There is one more thing you need to know before we go though, and that is how to read SELinux logs. Let's cover that topic real quick. So how do you read SELinux logs? Well, first you need to know where those logs are. Your SELinux logs are kept in var log audit.log. The audit.log contains more than SELinux logs, so we're gonna have to filter it down a little bit to get the SELinux info only. How do we do that? Well, we use the grep command to filter it first. Then we do avc, then we point it to var log audit.log. And there we go. As you can see, it shows us type avc and then it gives us SELinux logs. So this log message looks pretty complicated, but it's rather simple once you know what to look for. So let's break it down. Let's look at the first part of this message right here. avc denied map. This part basically tells us SELinux denied a request. So avc denied map means that SELinux is denying something. The next part of this log is com httpd. What that basically tells us is that the httpd process, otherwise known as Apache, was the process trying to make the request. The third part of the log is the file. So if you pay attention, it says path equals web/index.html. So what that means is so far we have a denied request from the httpd process, and it's trying to access the file web/index.html. After that, it gives us our source context. That's the part in blue. It says S context, and then it gives us the user label, which is system. It gives us the role, which is system, and then it gives us the type, which is HTTPD. Last of all, we have the destination context part of the log. So if we pay attention, you'll see under our destination context, our user is unconfined, our object, our role is object, and our type is default. So even though this log is somewhat complicated at first glance, if we take our time and break it down, it's rather simple. First, SELinux denied our request for HTTPD to access web/index.html, and it denied that request because the source and destination context labels do not match. And that's it. That is all the information you need to know for chapter 22, managing SELinux. Would you believe me if I told you that was a brief summary of all the things SELinux can do? It's very in-depth. That was almost 30 minutes of me talking and editing. So I hope you enjoyed this content. If you would like more Linux content, please subscribe to the channel, leave a comment below, and thank you for your support.